example, we'll work it in reverse. Okay. The acceleration of a moving particle is given by the following function. So this is a vector function, and it's 4ti plus 60j plus k. And what we know, the initial velocity and acceleration, initial velocity and position. So the velocity at the time of 0 is simply I minus j plus k, and the position at the time 0 is 4ti, is simply I, that's it, just I. Find the velocity and position. Find the particle's velocity and position. In other words, we'll have to integrate. So this exercise is really a calculus 1 exercise, except we do it with a vector value. All right. So since we have the acceleration, we're going to say that the velocity will be the integral of the acceleration vector. So we integrate term by term, and we have 2t squared in the I direction, and we have 3t squared j plus tk plus some vector c. Okay? So how are we going to find the vector c? Well, we'll see what happens when t equals 0. So v at 0, if you put everything, you replace everything with 0, all those the ijk term disappear, and what you have is that vector c, and you know from the data that it's I minus j plus k. Okay, so put this together, and you have v of t will be, in the I direction we have 2t squared plus 1. In the j direction we'll have 3t squared minus 1. And in the k direction we'll have t plus 1. And that's how you eliminate the constant vector c. Now, to find the position, we integrate one more time, and we have, this will be 2/3 t cubed plus t in the I direction, t cubed minus t in the j direction, and t squared over 2 minus plus t in the k direction, plus and let's call this C1, and now we have C2. Okay. Again, we check what happened at the initial position. Well, R sub 0, everything else will go to 0. Yes, because we have only terms containing t. So 0i, 0j, 0k, and what we have is this constant vector C2, and it's equal to I. Okay, so finish this up. R of t equals in the, we have only the I component to add, so it will be 2/3 t cubed plus t plus 1 I, and then the rest will remain the same, t cubed minus t in the j direction, and t squared over 2 plus t in the k direction. And this is the result. So we have the position, and also we found the velocity. As I said, this is a straightforward, there is no new technique here. I just want to emphasize that even if you have indefinite integral, if you have the initial position or any other position, it's convenient to work with initial value. What happens when t equals 0? Because a lot of times stuff disappears. But if we had the position at the, or the velocity and acceleration at the velocity and position at t equals 4, we still could find the value of the constant C1 and C2 and replace those. All right, folks, thank you so much. We meet again on Friday here.